I'm Nick Sanford, and this is my final project for CSCI E222, Foundations of Large Language Models at the Harvard Extension School in the spring of 2026. The project is called Whisky Recommendation via Semantic Search. It's a text-based recommendation system using transformer embeddings. Sometimes when I'm trying to find a new whiskey that I will enjoy, I'll struggle to get meaningful results from Google, but it's not from a lack of information, it's a lack of consistent wording. For example, if you grew up in Alabama and you want something that tastes like a campfire after a rainstorm, you're probably not going to go into Google and type in phenolic with coastal iodine into the search box. But that's exactly the type of language that professional reviewers will use. The question is, can a large language model bridge that vocabulary gap? Can we build a system that understands that swampy bonfire and heavily peated with maritime character are actually describing the same thing? That's what this project explores. Here's an example of what I just talked about. I apologize for reading from the slide. You could have someone from the South who would call it swampy like a bonfire pit after the rain. You can have an expert somewhere who's had 1,000 whiskeys in their life that says phenolic maritime with coastal iodine. Or you can have someone in a different part of the world who calls it smoky medicinal, very distinctive. All three of those are describing the exact same whiskey. Let's take a look at our data set here. From thewhiskeyedition.com, they have an open license API where you can pull down expert reviews of different whiskeys that they've tried. It's two guys did this review. They're from Germany. They have 508 reviews, and they categorize their whiskeys into one of 6 different flavor classes: delicate, mellow, rich, spicy, floral, and peaty. That's what we're going to try to tap into. We're going to use a large language model that has embeddings with 384 dimensions into the vectors. We're going to look at 2 different models. The baseline model, the TF-IDF model, it's very simply a word search model. So we're going to take our test data set, compare it to our corpus of 508 documents, and we'll simply ask, does this word exist in that corpus, yes or no? And so the swampy bonfire may come back with 0 because the word swampy is not in the corpus. We're going to compare that to our semantic model, the all mini LM L6V2 model, 384 dimensional vectors, which will embed our reviews, both our reviews and our test data set into a vector space, and we'll put similar concepts together. So swampy will be placed semantically very near the term peaty. And so we will still get a hit, a value, even though the word swampy is not in the corpus. So the out of vocabulary problem, this is the swampy thing that I'm talking about. Let's run through an example of that real quick. Let's say that we want to find a whiskey that is smoky and phenolic with maritime iodine, coastal brine, and a long medicinal finish. That happens to be the type of words that are used in the corpus. So when we do the TF-IDF matching, we're going to match on a whole bunch of those words, and the TF-IDF will return high values. We'll get good matching. The semantic is going to match because it's using the same words, it's going to be returning the same concepts. And so the semantic model should also have similar high matches in the corpus. Let's look at the query number 2. Smells like my uncle's bonfire pit after a rain. Tastes like licking a swamp log. Burns clean. That is obviously not the type of wording that a professional would typically use to describe a whiskey. Because these words are not likely to be in the corpus, the TF-IDF is going to collapse. It's going to go to 0 or near 0 because those words just aren't there. On the other hand, we haven't changed the concept at all of what we're describing. And since the concept still stays, the semantic mappings, the embeddings, are all going to still be in the same area of the vector space. It's going to have a similar cosine similarity. It will still return a good match. So we expect that in the second situation, the semantic model will be superior to the TF-IDF model. We're going to do that. We're going to do this measurement using precision at 10. So we have 508 documents in our corpus. And I went out to Reddit and I found 30 Reddit reviews of whiskeys. I picked whiskeys that I knew would be a good match. They were in the corpus and made sense to really kind of compare them, was the idea. I pulled 5 reviews per flavor class. So we take each one of those reviews and we compare it to all 508 reviews in the corpus. In the TF-IDF case, we ask, is the word in it? Is it not in it? Get some sort of percentage of words that are in there, and we get a score for how frequently words are in the corpus documents. On the semantic model, we embed both the corpus documents and our Reddit reviews into vector spaces, and we do a cosine similarity, which is going to be a dot product in this case, and we get a score for all 508 of the corpus documents. So in each case, we'll take the 10 best scores, either from the TF-IDF or from the semantic model, and then we will look at the flavor classes that are in those corpus documents, and we'll compare that to the flavor class that was in the Reddit review. And whatever percentage of the corpus documents correctly match the review flavor class, that's the precision at 10 metric that we're going to use. This is the result of doing that. So let's first look at the delicate match. You can see that the semantic model did outperform the delicate. That means that the model understood the concepts behind delicate flavors and was able to create a superior match, exactly what we expected. What we did not expect is that floral, mellow, peaty, and spicy, all the semantic model performed worse than the TF-IDF model. What that means is the vocabulary that's traditionally used for those flavor classes is robust enough, is consistent enough across the world that the semantic model was not necessary to create good matches. On the other hand, rich had a wonderful return on the semantic model. What that tells us is words are traditionally used to describe rich are used in many different ways. They're used across different flavors, not just one particular type. So the semantic model was able to distill apart where the terms that describe rich met the concept of what the corpus documents were, not necessarily the words exactly. So that one returned much better than we expected. This is the UMAP presentations, two-dimensional groupings of these 384 dimensional vectors. This is the core of the whole project. When I get done talking about this, I encourage you to pause this video and go stare at these maps for a while. This will really tell you everything you need to know about this project. So we take the 384 dimensions, we're going to warp the space in such a way that we can visually see it better in 2 dimensions, and we're looking for each of the flavor profiles to group together. For example, on the TF-IDF map, you can look at the light blue, which is the delicate flavor, and it kind of sort of clusters here at the bottom. Now, there's not as many blue dots up here at the top. Now, I'm not going to call that a clustering. It's still way too varied. But my point being that there is kind of more in one area. But what you see in the TF-IDF is across the flavor profiles, there is no clustering. The dots are everywhere. What that means is the words that are used to describe these 6 flavor classes the same words are used across all 6 classes. And so word matching across these 6 classes does not work very well. On the other hand, in the semantic model, and this is where you need to really focus when you pause the video, look at the peaty, the gray. The peaty flavors are clustered here in the upper right. Likewise, spicy, the medium brown, not the dark brown, medium brown, are also clustered here on the right. That's exactly what we want. The semantic was able to take the words that describe peaty and spicy and figure out the concepts and put them together. The other four flavors are scattered around, and so there is no clustering on those. So again, the concepts of those four flavors, not even the words, the concepts of those four flavors are blurred. We don't really understand how they are different between each other. Even between the peaty and the spicy, they're clustered in the same area. And so there's not a good definition between the two of those. Pause here, stare at this map a bit. It's very informative. So here I gave a quick example. We're going to run rich Christmas cake with sherry and dark fruit, and we run it through the TF-IDF and the semantic models. The TF-IDF returned 2 hits with mellow, 3 with rich. The correct answer is rich. The semantic model did a better job of selecting rich more frequently than the mellow. So the semantic model did a better job of matching the 508 corpus options to what we were trying to find, the rich Christmas cake. I'll also say Glenrothes 12-year Oloroso would be a perfect match for rich Christmas cake with sherry. So the semantic model did a wonderful job of figuring out the correct answer. Some quick strengths and limitations. Semantic model clustered the peaty and the spicy really well. I like that, but it's clustered them together. So good concepts on how they review those two terms, but they are too similar to each other. The rich class, the semantic model did fantastic with. It was able to get the concept that people would write about significantly better than the words that were used by those people. Some limitations. This is limited to 2 people who created the reviews. Really needs to be a much larger group of people doing that. And also from the Reddit reviews, people would drone on about other topics, the weather or how their dog came into play or just the experience they were having with the whiskey. That negatively impacts these scores. So really that needs to be cleaned up in some sort of way. For the future, most importantly, the number one takeaway from this, the semantic model absolutely works, but you've got to get better labels. The 6 flavor classes need to be well defined, and we need to create, before we do the reviews, decide what would qualify for each of the 6 classes. That's the number one thing. Number 2 thing is query pre-processing, which is to take out that flavor descriptions and use that and throw away all that other situational information, about the dog and the weather and all that kind of stuff. And of course, try bunches of other models. You can combine models, do whatever you'd like to do. So with that, thank you. Please enjoy your whiskey. If you do not like what you are drinking, then don't drink it. And obviously, of course, please don't drink and drive. Thank you.